Question 20. We have to find the exact value of x. Okay, it's a right angle triangle. We're going to use SOHCAHTOA here. You have adjacent. This side is adjacent. This side is opposite. So opposite and adjacent are like the sides involved, and we are given one angle. We know that the trigonometric ratio which will involve the opposite and adjacent is tan. So tan of 30 degrees, tan of the angle is equals to opposite, which is 6, over the adjacent, which is x. Now the thing is, we need to find the tan 30. We won't be allowed to use the calculator. So what we will do? Okay, there is an easy term. With the help of that triangle, we would be able to find the values of 30 and 60 degrees trigonometric ratios. Okay, let's say you have a right angle triangle. You have an equilateral triangle, and each side of an equilateral triangle is 2, right? It's an equilateral triangle, so each angle will be 60 degree. Yeah. Let's say you drew a perpendicular from one side, making an angle of 90. In an equilateral triangle, if you will draw a perpendicular, it will cut each length into half. So the total is 2. Now this will become 1, okay? And this will become 1, 2, right? So, and also it bisects the angle as well. So this angle will be 30 degrees now, okay? And this will be 30 degrees too. So you can now use both of any of these two triangles, right angle triangle. I'm using the left hand side one. Okay, remember with this triangle, you will be able, so this length is 1, this is 90, that's 30 degree here, and that's 60 degree, and this length is 2, okay? We can find the height using the Pythagoras theorem. So this is the opposite side, okay, according to 60, yeah, or you can say that's the height. So we apply the Pythagoras theorem here, which says 2 square is equals to height squared plus 1 squared, yeah. The longest side is 2 now, so we always keep we always keep the hypotenuse square at first, okay. And 2 square will be 4 is equals to h square plus 1 square will be 1. Move 1 to the other side. 4 minus 1 is equals to h square. H square will be 3 and h will be root 3, yeah. So this length is root 3, okay. Now if you are looking at the 30, so this is your opposite side, and this is your adjacent side, okay. The side between theta and 90, okay, is your adjacent side. So here you would be able to find the sine, tan and cos 60 and 30 values using this triangle rule, okay, this equilateral triangle rule. So you can easily find the tan 30, or if you don't want to do this, you can learn the values for 30 degrees, 45 degrees, 60 degrees and 90 degrees, okay. It won't be hard. There will be the table. You would be able to solve the values easily for them, okay. So for now we will get tan 30 as opposite over adjacent. So tan 30 from this triangle is opposite, which is 1, over adjacent, which is root 3, yeah. So I will put the value for tan 30 as 1 over root 3 here, is equals to 6 over x. We need to find x, so we cross. This whole thing was just to find the value for tan 30, okay. Since you are not allowed to use the calculator, I will tell you the easiest way. You better learn the values, okay, for all 30 degrees, 45 degrees, 60 degrees and 90 degrees, right? So you don't have to do this whole lengthy work here. Okay, so now we cross multiply to get the x. That will then become x times 1 is x is equals to 6 times root 30. 3 is 6 root 3. So that is your x value, 6 root 3, okay. The exact value of x is 6 root 3 centimeter, and this is worth 4 marks question. Question 20. Question 21 are vectors. O, A, B, C is a rhombus and O is the origin. O, A, B, C is a rhombus. We know that the rhombus lengths are equal, okay, all the 4 lengths are equal, so they are diagonal, and P is the point of intersection where the diagonals cut each other, right? Oh, I'm unable to use my, yeah. The diagonal of the rhombus intersect at P. So this is the point where they intersect, okay? OP is 2m, O to P is 2m, AP is n, A to P. The direction is from A to P is n vector. Find in terms of m and n in its simplest form OA. So we gotta find OA, O to A. So this is the length we wanna find now. To go from O to A, we can simply follow the path from O to P and then P to A, okay? Let me write it here. If you wanna go from O to A, you can go to O to P and plus P to A, okay? So we know that OP is 2m vector plus PA. We are not given PA, we are given AP. AP is given to be n vector, but if we will go reverse, if we will find P to A, we will reverse the sign, okay? Because we are now changing the direction, we are going from P to A. So we will reverse the sign, that becomes negative n, okay? So negative n. So that becomes, OA becomes 2m vector negative n, okay? OC. Part 2 is we gotta find O to C. Okay, so now you have to go O to C, okay? To go from O to C, you first have to go O to P and then P to C, okay? Yeah. So to go OC, you can go O to P plus P to C, okay? But the condition is you should know if the values are given for those vector lines. You are given O to P, that is 2m, okay? So we will write 2m. But the thing is, we are not given P to C. Do you have P to C? No. But since we know P is the point of intersection of the two diagonals, so these length will be equal, okay? AP and PC, and it's a rhombus. In rhombus, just like square, we get the equal length for the diagonals, yeah, if they get intersected. So if that's n, this is gonna be n as well, yeah. So P to C, because we are moving in the direction downwards, so P to C will be n also. So your OC is 2m plus n, okay? That was for the part 2 of part A. Now D is the point such that AD is 10m minus 3n. Okay, now D is the point on this rhombus such that AD length is given, but we don't know where D is. Show that OADC is a trapezium. OAD, we don't know where D is, and C, okay? Where should be the D so that it will be proved a trapezium? You know what a trapezium is? A trapezium is a polygon, a quadrilateral, in which you get the one parallel pair of lines, okay? Like this. If these two lines are parallel to each other, okay, then you join the other one, but the other one shouldn't be the parallel thing. So we get the trapezium this way, okay? How can you get the trapezium in this case? If you're having AOC here, that's your A, here's the O, and here's the C. Where should the D be? Where should the point D be? So that you can prove OADC to be the trapezium. In trapezium, you make sure you get a pair of parallel lines, okay? So I believe D should be somewhere here if I want to make it a trapezium, okay? Because you will notice if I'll be joining O with C and C with D, okay? I'm unable to remove this thing. I just gonna go make a line like that. Okay, it will go this way, yeah. So yeah, I think you can prove OA and CD parallel to each other, okay? In order to get the point D, OA and CD can be made parallel to each other. Okay, and now we join A to D and O to C. Okay, so this is, here you're getting a parallel line set that makes it a trapezium, but we have to show it. How do you prove two lines parallel? What does it mean? Let me just write the things first which are given. You have O to C, I guess. You have OA, which is 2m minus n, 2m minus n. You have OC, which is 2m plus n, 2m plus n. Okay, that's 2m plus n. And you have AD, it is mentioned AD is 10m minus 3n, 10m minus 3n. Okay, if we want to show OADC is a trapezium, we have to show OA should be parallel to CD. And how we will prove these two lines parallel to each other? If you were able to write OA vector as some lambda factor times the CD, okay, like if OA and CD are equal in length but multiplied some other factor lambda, some constant number lambda, then OA and CD will be parallel to each other. Okay, if OA is parallel to CD, then OA can be written as the lambda times the CD. Okay, so we need to get CD first. CD, how do we get CD? How would you get CD? Okay, to go from C to D, you have to go C to O, O to A to D. Okay, so C to D will be C to O, O to A, and A to D, right? Okay, in order to get CD, I think we have CO. CO we are reversing, we are moving in the reverse direction, so that will be minus 2m minus n. Okay, and you are moving in OA direction, that will remain plus 2m minus n, plus AD, we are moving in AD direction because we are given AD direction, that is plus 10m minus 3n. Okay, here you will get the CD, minus 2m plus 2m is gone, minus n, okay, and then you get 10m, and then minus n minus 3n is minus 5n. Okay, so that is your CD, which is 10m minus 5n. Okay, now you want to prove this thing. If OA and CD are parallel, then OA should be equals to some lambda times of CD. Lambda is a constant number here. So OA, let's write OA, which is OA is 2m minus n is equals to lambda, we don't know what lambda is, CD. CD is 10m minus 5n. If you take 5 common from both of them, you get 5 times 2 as 10m minus 5 times 1, 5n. Okay, and that's mn, am minus n, 2m minus n. Okay, you notice this is OA and CD are equal to each other. Yes, they are equal, but lambda times something. Okay, lambda factor multiplying with something in order to make them equal. So yes, that lambda is 5 here, which proves that OA and CD are parallel to each other, and if they are parallel, OADC is a trapezium. Okay, that is what you wanted to prove for question number B, part B. Okay, so we are done with question number 21. Now question 22. The curve has equation y equals x bar n plus q x bar 2 plus 9x. The derivative of this curve is already given. We have to compare the things and then find the value of n and q. Yeah, see, how do you get the derivative of something? Dy by dx, the power times the first number, which is n, x to the power n minus 1, 1 less in the power, plus 2 times q makes it 2q, and x to the power of 1 less in the power makes it x power 1, plus 9x derivative will be just 9. Okay, now we compare both of these derivatives in order to get n and q. Now we compare both dy by dx, so 3x square compared to n times x power n minus 1, so n will be 3. Okay, And now if you compare the x's, minus 12x compared to 2qx, x with x, you get minus 12 is equals to 2q. Divide both sides by 2, you get q as minus 6, okay? So n is 3, q is minus 6. Now part B, work out the coordinates of the turning point of the curve. Turning point of the curve, whenever you hear a word turning point, it means that you have to put dy by dx equals to 0 always, okay? So here is your dy by dx, which is 3x square minus 12x plus 9. You keep it equals to 0 in order to get the turning point's coordinate. So as you can see, this whole equation we can simplify it by dividing. Let me put on a charger first. Okay, so by dividing everything by 3 gone, it's x square minus 4x plus 3 by 9 by 3 is 3 is equals to 0. Now you factorize it. It is 1 here. 1 times the last number gives you 3. Okay, two numbers that multiplies to get 3 but adds up to negative 4, which will be negative 3 and negative 1, okay? Because when we multiply negative 3 with negative 1, it gives us positive 3. When we add negative 3 and negative 1, it gets us negative 4, okay? How will you write it? You write two brackets with x and then negative 3 and negative 1 here. So keep both of them equals to 0. You will get x is equals to 3 and x is equals to 1. So these are the x coordinate of the two turning points. We want to find out the coordinate. We have just found the x coordinates for the 2 points, okay? We want to find out the y's as well. How do you find the y? When you substitute the x back into the equation, function equation, you will get the y. You know y is x power n. Let me write it here. Plus qx square plus qx square plus 9x, yeah, plus 9x. But the thing is, we have to replace n and q values also. N is 3, so x power 3. Q value is minus 6, okay? We found it in the part A. So minus 6x square plus 9x, okay? So first I will replace x with 3 in order to get y. So y is 3 power 3 minus 6 times 3 square plus 9 times 3. Y is equals to 3 power 3 is 27 minus 3 squared is 9. 9 times 6 is 54 plus 3 times 9 is 27. 27 and 27 gives you 54 and then it's minus 54. So y will be 0, okay? When x is 3, y is 0. When x is 1, what will be the y? So y is x power 3 minus 6x square plus 9x. You replace x1. So y will be 1 cubed minus 6 times 1 squared plus 9 times 1. And y will be 1 minus 6 plus 9. Y will be 1 minus 6 is minus 5 plus 9. Minus 5 plus 9 is 4, okay? Minus 5 plus 9 is plus 4, okay? Y is plus 4. So these are the two coordinates for the turning point. One of them is 3, 0. Okay, we have got the brackets. I'll be writing 3, 0 or with black 3, 0 and the other is 1, 4. So you should know that to find the coordinates of the turning point, you put dy by dx equals to 0 always, okay? So this is the question 22 for the differentiation. Question 23 and the last one, I guess. Yeah. So question 23 is the last question we have here, which is 2x squared plus 10x over x squared minus 25. We have to simplify it. So first we can see from the top I can take 2 as common, okay, and the remaining 2x, there is 2, we have to factorize the top, So I have 2 and x in both of them. So what stays in the bracket? I took 2x out, so only x will stay here. Plus 10 divided by 2 is 5. So I'll write 5 here. X is already out, okay? Okay, in the bottom, you know the square identity, that if you have the square over a and the square over b with the minus between them, how you can open them? You put a plus b without the square and a minus b without the square, okay? Since we know that we can write 25 as the square of 5, how do we open that? Now we have square over x and the square over 5 with a minus between them. So we can write it x plus 5 times x minus 5, okay? So this x plus 5 on the top and x plus 5 in the bottom, we cancel it out, and the remaining thing is 2x over x minus 5. We can't simplify it anymore. So this is your final answer, simplified answer for question 23. So we are done with this paper. All the 23 questions solved, and this is it. Yeah, thank you.